Good morning everyone. I am Annapurna, working as an assistant professor in the Department of ECE at Institute of Aeronautical Engineering. Today we are going to discuss about some of the AC bridges which are used to measure unknown capacitance and inductance. As we know that we have two types of bridges, AC bridges and DC bridges. AC bridges are helpful to measure unknown inductance, capacitance and resistance. At the same time, DC bridges are helpful to measure the unknown resistance. So whether it is an AC bridge or DC bridge, any bridge consists of 4 arms. So if any electrical component arranged in the form of a bridge network, then that is called as a bridge. This is a DC bridge. In this DC bridge, finally we are going to measure unknown resistance. So we have two types of DC bridges to measure the resistance. One is Wheatstone bridge and another one is Kelvin bridge. With the help of Wheatstone bridge, we measure the resistance, but that is medium resistance. If the resistance value is too low or if the resistance value is too high, then it is very difficult with the help of Wheatstone bridge to measure the resistance. So that we go for the Kelvin bridge. Why it is very difficult with the help of Wheatstone bridge means, if the resistance value is very low, then the leads which are connected to the unknown resistance may get problem due to low resistance. So that in Kelvin bridge, the unknown resistance, if you consider a bridge, this bridge consists of 4 arms. Those 4 arms are R1, R2, R3 and Rx. This Rx is called as unknown resistance. To measure this unknown resistance Rx, we need to connect the lead of the unknown resistance with another terminal which is connected to the galvanometer. The resistance is connected to the leads which are connected to terminals A and C. Instead of directly connecting the unknown resistance to the resistance R3, in this Kelvin bridge we connect the unknown resistance to a point C or A, so that the lead problem can be avoided in Kelvin bridge. This is the main advantage of Kelvin bridge. With the help of Kelvin bridge, we can measure low resistance value. This is the advantage of Kelvin bridge. Next, coming to this Kelvin bridge, to measure this unknown resistance Rx, the bridge consists of 4 arms R1, R2, R3 and Rx. So, to measure this unknown resistance Rx, we have to consider the point A and point C also. The point A to C is represented with another unknown resistance that is called as Ry. Now, by considering the balanced bridge condition, we can measure this unknown resistance Rx. In the Kelvin bridge, the balanced bridge condition can be obtained as, if Rx is placed instead of this Rx and R3, only we have 2 terminals, that is point C and point B, then the balanced bridge becomes RBC by RAB equal to R1 by R2. In the first case, assume that instead of this Rx, we have a RBC resistance. Similarly, instead of this R3, we have the resistance RAB. So that RBC by RAB equal to R1 by R2. And another condition by using this resistance is RAB plus RBC equal to RY. And third statement, when we have resistance Rx and R3 along with this RAB and RBC, then the balanced bridge condition becomes Rx plus RBC by R1 equal to RAB plus R3 by R2. Okay. So in this is the third condition. When the bridge is present in the balanced condition, the generalized expression is Rx plus RBC by R1 equal to R3 plus RAB by R2. Now, to solve this Rx, we need to measure this. To measure this Rx, we need to calculate RBC and RAB. If we know RAB and RBC values, we can measure the unknown resistance Rx. So that to get this RAB and RBC values, consider equation 1. Consider the first equation, that is RBC by RAB equal to R1 by R2. To solve this equation, add plus 1 on both sides. To solve this equation, add plus 1 on both sides. While we are adding plus 1 on both sides, after simplification we have LCM as RAB in left hand side, then we have RBC plus RAB, which is equal to, by taking LCM on our right side, that is R2, then we have R1 plus R2. Now, the expression RBC plus RAB by RAB equal to R1 plus R2 by R2. In this equation, RBC plus RAB represent what? RY. So, replace this RBC plus RAB equal to RY by RAB equal to R1 plus R2 by R2. Now, take cross multiplication here. Then we have RAB equal to R2 RY by R1 plus R2. Similarly, by substituting RAB value in the second equation, we have, by substituting RAB value in this equation, we have R2 RY by R1 plus R2 plus RBC equal to RY. Then RBC becomes RY minus R2 RY by R1 plus R2. By taking LCM here, we get the expression for RBC as R1 RY by R1 plus R2. So, if you observe here, RBC equal to R1 RY by R1 plus R2. Now, we have the expression for RAB and RBC. RAB equal to R2 RY by R1 plus R2. Similarly, RBC equal to R1 RY by R1 plus R2. Now, substitute RAB and RBC in the third equation. Then we have Rx plus RBC. In place of RBC, take R1 RY by R1 plus R2 whole divided by R1 equal to RAB. RAB means R2 RY by R1 plus R2 plus R3 by R2. The same equation we can rewritten as Rx plus R1 RY by R1 plus R2 equal to, by taking this R1 onto right hand side, we have R1 by R2 into R2 RY by R1 plus R2 plus R3. Now, the expression and this one will be cancelled, and finally Rx equal to R1 R3 by R2. Unknown resistance Rx can be obtained as R1 into R3 by R2. This is the unknown resistance that is present in the Kelvin bridge. This resistance has very low value. Rx equal to R1 into R3 by R2. This is a DC bridge. In this bridge, we have 4 arms. Those 4 arms are represented with R1, R2, R3 and R4. This fourth resistance is the unknown resistance. As we want to calculate the unknown resistance with the help of Wheatstone bridge, the resistance should be medium value. If the resistance value is too low or too high, we cannot measure with the help of Wheatstone bridge. In such cases, we go for the Kelvin bridge. In this Kelvin bridge, the resistance, the unknown resistance is not at all directly connected to any other known resistances. Instead of that, the unknown resistance is connected to another leads. The leads of the unknown resistance are connected to the another point which is indirectly connected to the galvanometer. In the construction itself, two opposite arms of the bridge are connected to a galvanometer and the remaining two opposite arms are connected to the potential. So this is the construction of Kelvin bridge, and finally in the Kelvin bridge we can measure the unknown resistance Rx with the help of points RAB and RBC. Finally, the unknown resistance Rx equal to R1 R3 by R2. This is unknown resistance measurement with the help of Kelvin bridge. Along with this, we have one more AC bridge, that is called as Hay bridge. Already we have discussed about different AC bridges. This is one of the AC bridge which is used to measure inductance value. With the help of this Hay bridge, we can measure the inductance with very high accurate readings. So in this Hay bridge, similar to the AC bridge, DC bridges, in this AC bridge also we have four arms. The four arms of the bridge are represented with first arm with Z1, Z2 and Z3 and Z4. After calculating impedance across each arm, finally we need to substitute all the impedances in the balanced bridge condition, that is Z1, Z4 equal to Z2, Z3. Finally, we can measure Z4 with the help of balanced bridge condition as Z4 equal to Z2, Z3 by Z1. So, Z4 means which consists of unknown inductance and unknown resistance. The unknown inductance and resistance can be measured with the help of balanced bridge condition. Coming to the Hay bridge, the first arm consists of series combination of resistance and capacitance, so that Z1 can be represented as R1 plus 1 by J omega C1. So that we can represent this Z1 as Z1 equal to 1 plus J omega R1 C1 by J omega C1. Similarly, Z2, the expression for Z2 is R2 and the expression for Z3 is R3, and Z4 can be represented as again series combination of resistance and inductance, that is R4 plus J omega L4. Now substitute Z1, Z2, Z3, Z4 in balanced bridge condition, that is Z4 equal to Z3, Z2 by Z1, that is R4 plus J omega L4 equal to R2 R3 by 1 plus J omega R1 C1 whole divided by J omega C1. That expression can be rewritten as R4 plus J omega L4 equal to R2 R3 into J omega C1 by 1 plus J omega R1 C1. So to simplify this expression, first of all see that the denominator consists of an imaginary term. So for any equation there should not be any imaginary term in the denominator. So to remove the imaginary term in the denominator section, we have to multiply the entire equation with 1 minus J omega R1 C1. So R2 R3 into J omega C1 whole divided by 1 plus J omega R1 C1 into 1 minus J omega R1 C1 by 1 minus J omega R1 C1. Now we have R2 R3 J omega C1 minus omega square R1 C1 square R2 R3 by 1 minus omega square R1 square C1 square, which is equal to R4 plus j omega L4. From this equation, if you equate real terms on both sides, then we get the expression for R4. Similarly, when we equate imaginary terms on both sides, we get the expression for L4. So first of all, equate the real terms on both sides. The real term is this one. Then we have R4 equal to minus omega square R1 C1 square R2 R3 by 1 minus omega square R1 square C1 square. Similarly, by equating imaginary terms on both sides, then we have L4 equal to R2 R3 C1 by 1 minus omega square R1 square C1 square. This, it will be plus. R4 equal to omega square into R1 square C1 square R2 R3 by 1 minus omega square R1 square C1 square. So here j square means minus 1, minus into minus plus. So finally these two are the expressions for unknown resistance and unknown inductance. So with the help of Hay-Bridge, we can measure unknown inductance which have more accurate value. This is about one of the AC bridge, that is Hay-Bridge. This Hay-Bridge is mainly used to measure unknown inductance. Whether it is an AC bridge or DC bridge or any bridge, if it is an AC bridge, we need to substitute impedances across each arm in balanced bridge condition. Similarly, if it is a DC bridge, measure resistance across each arm and then substitute in balanced bridge condition. Finally, whether it is an AC bridge or DC bridge, when we substitute impedance or resistance across each arm in a balanced bridge condition, then we can measure the unknown parameter. That unknown parameter may be either inductance, resistance or capacitance. So in this class, we have discussed about Kelvin bridge. This is an DC bridge which is used to measure unknown resistance, and second bridge is a Hay bridge. This Hay bridge is used to measure unknown inductance. These are the two bridges we have. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.